This is gold. You don't want to miss this.
It's true. I'm glad you think so too. So we will wait another couple of minutes. You can also follow us on Twitter. You're here, so you don't need me live tweeting it. But if you would like to engage with us on Twitter, we are at IET_biomed. I'm going to check that because I'm pretty sure we are. Yes, we are, in case you would like to follow us. Okay, so we're doing pretty well on numbers. I'm going to give it a couple of minutes and then I will introduce our speaker and then disappear into the background and leave him with the stage.
Oh, that should be me on a blank screen. God.
Yes, it will.
Do you host all the webinars, Shruti?
No, between me and Jack, we do them. No, as I think a lot of people who have, if we do have some people, I think in the audience who have been to some before. So yeah, they will have people. I'll introduce myself, do not worry. Okay, I'm gonna get cracking. So hi everyone who has joined us. Thanks for joining us on this Wednesday evening. My name's Shruti. I am co-chair of the biomedical engineering group. As Nate has alluded to, you probably won't have seen me before. Jack's done the last couple of webinars, who is my co-chair. This evening, we have Nate here to talk to us. He is the founder of Koalaa, the soft prosthetics company, and he's going to talk to us about his journey. So a little bit from the business side, a little bit about experiences, a bit about the tech as well. And so yeah, I don't want to steal his entire talk, so I'm not going to say much more than that. But he really wants this to be sort of a conversational one. So I know that a lot of the time we have slides and then you hold out a few questions and then they get answered at the end. Nate doesn't like public speaking, so we've happily put him on the spot here. So please do keep the chit chat as usual and ask your questions through the Q&A, and we will be monitoring them throughout. So Nate will try and adapt his talk and answer your questions as we go along as well. So if things come up as he's talking, put them in that Q&A and we'll get them answered for you. I have put the CPD link for anyone who wants a CPD certificate into the chat. And also, if you are on Twitter, want to tweet about this, we are at IET_biomed, and I'll also put in Koala's as well. They are at Koala Community. But I think that is everything from me. So Nate, all yours. Feel free to introduce and get going.
Get going. Oh, thank you. Oh, pleasure. No, thank you, Shuji. Yeah, thank you for inviting me. This is actually really cool to be able to chat to everyone. I can't see anyone, but I assume there's humans there. So welcome. It's nice to meet you. As Shruti said, I'm vaguely allergic to presentations, so this would be so much more fun if it's more of a conversation. If I say stuff that's vaguely interesting that you want to ask a question about, just I think pop it in the chat, I'll see it and we'll just try and get it back and forward, which is hard because I can't see it all, but let's do the best we can. But yeah, so I'm Nate. I'm the founder of a prosthetics company, and we'll get into what that means, but in a nutshell, we look after people who have been born with limb difference. So maybe they've been born without a hand, without an elbow, without a forearm, and we try and meet these people and sit down with them and understand what we can do, what we can make to be useful, to that, help people do stuff that maybe they haven't had the opportunity to do before. And it's incredibly fun and rewarding, and every day is just epic. But it started a while ago, so I'll just sort of tell you the story of how I got here. And it started back in Imperial College in about 2016, which was my third year of a mechanical engineering degree. And for those of you who are students who have gone through that process, you'll probably know, basically, it's quite common for in your final years of a degree, you get into project teams and work on a project for the whole year. So that's what we did. We got into a team of 4 students and picked a set of projects that our supervisors had proposed that we thought looked interesting, and we got rejected for all of them. He didn't want us for any single one of them. So then we had a choice. We could either pick the projects that were left over, like the dregs that like no one else wanted to take on, or we could self-propose something. And a few days earlier, I'd seen on YouTube a video that literally contained everything I love about the world. It was a video of Robert Downey Jr., so Iron Man. If anyone who doesn't know, if you don't know, I can't believe that. But yeah, Robert Downey Jr., and he was, as himself, as Tony Stark, he had a robotic 3D printed prosthetic limb for a little boy that this engineer had designed from somewhere in the States. And he gave it was like Iron Man style. He gave it to the little boy, he put on his own arm, and they were sort of like high-fiving and stuff. I was like, this one video is just immaculate. It's everything I love about engineering and media. I think this is great. What a fun thing to work on. So for that reason alone, we thought this is a great opportunity to trick our uni into letting us build an Iron Man suit. Let's propose a project around robotic prosthetics. And that's how we fell into it. And they got accepted, and that was great. And that was really the initial accidental step into this world of prosthetics. Fortunately for us, very, very importantly, really early on, our supervisor introduced us to a guy called Alex Lewis, who is well worth a Google. He's got a documentary. He's an incredibly cool guy. He's a world traveler. You know, he raises money for all kinds of different causes. He's a designer as well. So he could communicate with us on like that kind of engineering, designery level about things that were useful in prosthetics. But he was also a quadruple amputee. So I think at this point, about 3 or 4 years prior, due to sepsis, he'd lost both of his arms and both of his legs. So it was awesome to meet someone who was actually using the prosthetic devices that we'd been thinking about, that we were going to revolutionize. And the first thing that struck us, and this might, some of you, if you're in the prosthetics industry, this might be obvious. If you're not, then you might be like I was at the time, where I had a sort of preconception about what prosthetics were like, and it was sort of based on what I'd seen in movies, and it was sort of based on what I'd seen at the Olympics, I guess, a decade ago now, and based on what I'd seen like Good Morning Britain. We kind of imagined this thing of like bionic limbs, like very high tech, very integrated to your nervous system. I basically thought the problem was sorted. I thought prosthetics were awesome. If we can land rockets, I kind of assumed prosthetics were a much easier problem to solve. But the first thing that struck us is that Alex, he wasn't walking in on bionic legs. He was in a wheelchair. And he wasn't wearing these all singing, all dancing, multi-articulated hand-shaped limbs. He had 2 very, very rudimentary hooks. And I've got one right here. I don't know if you can see my screen, but this is literally one of his arms. First thing that struck me was the hook right on the end, and this rigid casing, completely rigid, and you can't feel it, but it's quite heavy. This is over 1 kilogram. It might be 2 or so kilograms. It's quite a heavy device. I might try this. I want to try this. If no one writes anything, then I'll just answer it myself. But does anyone, or would anyone want to guess in the chat how much this arm costs? I'll leave it for a second to see if technology is working. Otherwise, I'll tell you some of the guesses I normally get. Oh, here we go. Oh, they're coming in. 200p, 2000. Okay, 200p would be a bargain for anything. £8,000, that's pretty good. 2,000, 1,000. This is working. This is awesome. Great. Okay, keep talking to me. And now I know you're there. This is fantastic. 10k. Okay, there we go. That's getting good. This specific arm, this literally one that I'm holding right now, £25,000. £25,000 for this. So this is like a really nice, brand new, like sedan kind of car. Yeah, it's math. Yeah, it blew me away. And this isn't even state of the art. So if you had like a bionic hand, you could imagine they can go up to, they can go up to 30, I've seen £50,000. If we're talking legs, like actual on movies and stuff, they can easily get into the hundreds of thousands of pounds. So this kind of blew us away. And Alex was explaining how once he lost his limbs, his life had to, any sort of ambition he had to do had to stop, and he had to focus his life around fundraising just to sort his prosthetics out for himself. Which is mad, because it got us thinking. I mean, if we live in one of the most privileged parts of the world, and if £25,000 is expensive to us, then for millions around the world that don't live in the UK and live in more middle and low income places, how the heck are people going to afford that? But we'll go on to that later. So this was the situation we were sort of faced with, and we asked Alex. We were saying, well, what do you find it? What would you want from your prosthetic? And this is when he really surprised us, because he wasn't asking for what we thought he would. He wasn't asking for what our academics had told us he would. Academics were saying more technology, better nerve integration, higher quality materials, use composites, all these kind of things. But what Alex was asking for was like, no, I'm wearing these things all day. Just make them really, really comfy. Just make them really, really, really nice to wear. Make them really simple to use, so I don't have to train for months to learn how to operate this hook and pick up stuff. Just make them really simple so I can pick them up and go. And make them easy to get, so that if I want a blue one, or if I want one to play golf in, I can just go and get it. I don't have to fundraise, beg my clinician to fund it for me. I can just get it myself. And those sounded like really down to earth problems, something that like a student could, get our heads around. And I'll tell the full story. So we heard all that, and essentially being students, being children of high tech kind of stuff that we see on TV, we sort of heard that, like, yeah, I hear what you're saying, Alex, but I think you want a bionic hand. I'm pretty sure you do. I'm pretty sure you want a bionic hand. We'll simplify the hand. So we decided we won't make it with 5 fingers, we'll make it with 3, and we'll sort of stylize it, and we'll focus it around certain tasks. We said we'll just get it to hold a pen, because he was a designer. He just wanted to draw, get it to use a mouse, do some office tasks, but he wants a bionic hand. That's what he wants. And so we spent about 9 months during that project. I was on the hand. we were perfecting this sort of hand mechanism to get the fingers to bend in a very specific way to grab stuff. 9 months on this first prototype, that we were like, oh, this is really simple bionic hand. This is great. But it came to the end of the 9 months. I had to hand him, we had to write and hand in our project the next day, and we got Alex in the day before. So this was really brown trousers time, but it's fine. We gave him this terrible prototype. And I cannot explain how bad this thing was. Essentially, we had this hand, but with all the love in the world, I couldn't get a hand that I'd made out of laser cut bits of material to hold a pen in. I'm trying to find one to hold like a pen in that kind of delicate grip that you need to write something with. To get a mechanical object to sort of hold something in that kind of tripod grip was just too hard. Like, this is a feat of engineering. The hand is amazing. So the day before, what I'd done is I got on Amazon and I got some 50 pen clips. I put one on the palm, so you clip the pen in, and then the bionic hand would close around it, and then it held it. I was like, okay, that'll do for now. Second thing is, we had this bionic hand that we built, and we didn't know how to put it. We really hadn't thought about how we're going to put it on him. How are we going to strap this to you? We didn't know how to make these kind of like laminated like sockets, and these kind of like very sophisticated form-fitting prosthetic sockets. So what we did have, though, was access to the costumes department at uni, and we had fabrics and we had sewing machines. We were like, okay, let's just make like a fabric bag and we'll just like tighten it on his arm and we'll go from there. So you can imagine this prosthetic was a hodgepodge. It was horrible. But he came in, we gave it to him, and he put it on. He was like, guys, this is awesome. And we're like, are you joking? That's the worst thing I've ever seen. What do you mean? And he was like, I absolutely love this pen clip. I was like, Alex, no. Look at the intricate finger mechanisms that I've built and all these intense, structures and all the analysis. And I was like, I don't need any of that. I don't need any of that. This pen clip holds the pen securely. I can write with it. This is brilliant. I love this pen clip. And you know what else I love? I love this fabric socket that you've made. Like, I've never had a socket that fits me perfectly first time. And that sort of hit us in that the bits that we'd spent all of our time and energy on, the bits that we'd assumed he'd wanted as a person who'd lost both of his hands, were the bits he did not care about in the slightest. And the bits that cumulatively had taken us 30 minutes out of a 9-month project to put together were the bits that he loved. And that really struck us. And actually his partner, his charity partner who runs his trust, said something that stuck with me at the end of that project. And she basically said, look, this is actually really cool. Like Alex and I would buy this now, but it doesn't exist. And it should. But the sad thing is actually that, we see lots of projects, we go to lots of unis, we work with lots of students, we see lots of cool stuff. I'll see if I can get a photo, actually. I'll see if I can get a photo. I'm very bad at multitasking. I'll try and get a photo of this terrible prototype. But I'll see if I can find it. But in the meantime, we work with lots of unis, lots of projects, but ultimately we see loads of cool ideas and the students move on to other things, and these really cool devices, that could help people in the real world, just get put in shelves and just left in people's drawers and in labs, and they don't see the light of day. And that really stuck with me because this has been the first time I'd ever felt useful, that I'd made something for someone and they'd use it and be like, you know what, this is cool. I would use this. And the fact that this happens a lot with young students and it doesn't get taken any further, and that people like Alex could be missing out on having access to things that would make their lives a little bit better, frankly, just ticks me off a bit. That doesn't feel right. So the last thing I'm going to do is drop this. And it was sort of then when we just decided, look, we love this. We love working on prosthetics. We love Alex. We love the problem that he's posed to us. We want to keep doing this, and we need a plan. We need a guiding set of principles. We need resources. We need other team members to make this happen. And it sort of struck us like, oh, that is what a company is. That is it. And I just read a book called 0 to 1, which, if you haven't read it, it's worth a read, by a dude called, he's the PayPal guy. I forget his name, but look it up. It's Peter Thiel. That's it. He's a questionable guy, but the book's good. So read the book. And the book basically is going through how, if you're a young student, you've just done a degree, you might as well start up something and see if you can make it work, because what have you got to lose? You can always go get a regular job later. And so we was in this mood, and we're like, yeah, let's try a startup. Let's embark on this journey, having no idea what that actually meant. So anyway, so that was our third year. That was our crappy prototype, and that got us into the world of prosthetics. The next year was my final year of uni, and this is when we decided, okay, let's do a startup, whatever that means. And I was really fortunate because at Imperial College there's a thing called the Enterprise Lab, and there's the entrepreneurship department. I don't even know what entrepreneurship meant. I still don't really know if I know, but there's lots of resources and people at Imperial, and I'm sure there are other unis, but I think Imperial was particularly good for this. There were lots of resources to just help students turn their harebrained ideas of like, okay, I'm going to make prosthetics, but I'm going to try and make them differently with fabrics and stuff. Turn people's harebrained ideas into actual viable companies. And by the way they do that, essentially match you up with people who've done it before and mentors, and you can talk about niche topics, and they have competition, so you can pitch your idea and potentially win a few £1,000s, which at that time, which still is, but like at that time, a few £1,000s is like it's like an infinite amount of money to a student to pursue prototypes and stuff. So my final year, we essentially we applied to every single like student competition that we could find to pitch our idea of essentially taking prosthetics, but making them really simple and really comfy and building them like clothes. And I'll show you one. I will show you one, I promise. Pitching this idea, and the first grant we won was for £500 for some materials. And at that point, a prototype cost us about £5 to make. So I was like, oh my God, we can make 5 times 100. We can make 1 billion prototypes. It's amazing. We've got so much money. 500 quid, that's epic. And that gave us the confidence to try for other ones, to try for other competitions. And it came to the end of that year where all these competition finals were in 1 week. They were also in the same week as a number of exams I had to do, my final year of uni. And also I had a job offer that I'd been putting off for about 3 or 4 months, actually signing the dotted line, because I wasn't sure whether this startup thing was going to work or not. So anyway, that's what I said to myself. If I win just, I've worked out a figure, it's something like 20 grand. I was like, if I win just about that enough money, that's just enough to sort of do everything I needed to do the next stages of the startup, which was file some patents and do lots and lots of user testing, and do like pilots and talk to more people. And there's just enough money with that to do those things and then sort of live on beans and bread for the year. So if I win that amount of money, I'll say no to the job. I'll just take the plunge. We'll do this. And so we pitched those 3 competitions. We were lucky enough to win a bunch of them. And I just got over that threshold. I was like, right, I guess that's it. I'm taking the plunge. So I called up my job offer. I also had a PhD offer because I was really hedging my bets here. But so I called up the job offer. I said, look, I'm really sorry that I've strung you along for, at this point, half a year. I'm really sorry. I've got this kind of idea. We want to make prosthetics. We want to make them affordable. I need to pursue it. And they were like, no, you need to do that. We'd be angry if you didn't. And if it all goes, belly up, then come back to us afterwards. We'll hire you then. It's fine. And so that was amazing. So that was sort of the jumping off point to be like, okay, this is actually it. And so I did. I lived on beans and toast for about a year, and just slowly started to recruit a team and meet more users and just go from step to step to step. So I should probably shut up and just actually show you the actual thing. So typical prosthetic, again, I don't know how many can see my screen and whatnot. Should you want the first prosthetic makers to receive that user feedback about comfort, cost, and ease of use? Why weren't existing companies addressing those concerns more? That's an amazing question. I'm going to read that out. So surely you weren't the first prosthetics makers to receive that user feedback about comfort, cost, and ease of use. Why weren't existing companies addressing those concerns more? So after we sort of going into startup land, I was looking up patents, I was looking up prior art and literature and stuff. There is countless, well, it's actually not, there's not a lot of literature in prosthetics, but there are many, many research papers into what are the factors that make a good prosthetic limb. And I think it's worth saying, I mean, like, maybe I sort of glossed over it, but all of these unique ideas came from Alex. Like, user feedback in this kind of field is not just nice, it's to have, it's not just helpful, it's necessary, because I have both my hands. So my opinion is irrelevant. Like, what I think is a good prosthetic arm doesn't matter what I think, it's what people actually use it. So people looked into this before, and the top 3 factors were always comfort. Like, comfort was the #1 factor why people stopped using stuff like weight and painfulness, and then functionality, like ease of use. They're always consistently the top 2 things that people hate about their prosthetics, and that's why they stop using them. Abandonment is really high. I think it's, depending on the device, it's anywhere between 70% or 30% to 70% of prosthetic limbs are just left under the bed. in the first year. So it wasn't new. This wasn't new insight. But I think what was maybe different is that we weren't prosthetists and we weren't from the field, and we weren't, we were engineers, and we didn't know what the state of the art was before we started designing things. So this feedback wasn't tweaking our current design, which was, oh, we're going to make this, how can we make this more comfortable, more easy to use? It was informing it. So it was like, let's start from those points. So that's probably maybe a good thing to point to show you what we make in that. So we make prosthetics like clothes. So it's very much like a sneaker, because we essentially looked at other things that people wear that are functional, but that are also comfortable. So like shoes, sportswear, shin pads, cycling gear, these kind of things. We're like, well, surely we can use those principles and just apply them to a prosthetic limb. So it's soft, it's rigid where it needs to be, but soft and flexible where it can be. So it's more like clothing. So you can make it really quickly and easily. You can fit it very quickly. Maybe I can like show you how that works in a second. But then instead of having really complicated like hands or even like hooks or electric things that are designed to do a bit of everything, we just have like task specific tools that clip on and clip off. So that each tool does something, it's designed to do one thing, and it's designed to do it really simply, like a toolbox. And suddenly it's something that means you can clip on and go. So when we're talking about ease of use, the general process with a traditional prosthetic is you need to find a clinician. They need to be highly skilled, because it's like an artisan craft to make something rigid fit a squishy limb. They'll take some castings of your limb, they'll fill it with plaster, they'll lay plastic sheets over it in their workshop. That will take a few weeks. You'll come back in, you'll try it on. It obviously won't fit first time, because humans change size, rigid stuff doesn't. And then you'll do that process over and over and over until you get something that fits. But if you lose weight, if you gain weight, you're screwed. You've got to start it all over again. It's also why it's so expensive, I think, one of the reasons. But with ours, the process is essentially send us a measurement and we treat it like clothes. So we get your size, we put it in the post and send it to you. And we work with all age ranges. So like as young as like, 3-month-old babies. But you can send this like a really young child. They'll pull it out of the box, put their arm in, and then a few minutes later they're off and they're skipping or they're playing tennis. It literally is like slip on and go. So it's a very different way of doing it. But I think the thing is, we look at solutions and we very much look at the person and say, look, what do you want to do? And in Alex's case, it was, I want to write. And so it's like, well, let's make the simplest thing that will get you to write, the simplest, most comfy thing that will get you to write. If that looks like a traditional prosthetic, fine. If it looks like something very different, then that's also fine. And we ended up with something very different. And that's kind of what we do. Every single new family we meet, we sit down and try and find a solution. And because we listen to them and just do what they tell us to, we end up with solutions that are quite different from what other companies do. And other companies are locked in their ways. I think a little bit, they're kind of stuck down their sort of path. So that's pretty much it. But yeah, I could ramble for ages. I was planning to chat for about half an hour and then sort of just let you guys fire questions in and maybe have a backward and forward. I see one there. So what is cost and abandonment left under the bed rates in your device? About 2 to 5%. In fact, we just did a study, didn't we? What was that? I think it was 7% in Sierra Leone. So, I'm not going to extrapolate that to the whole world, but that was an actual independent study. So that was good. That's 7%. So, 10 times better. And actually, of those 7%, what we normally find is with ours, if the reason someone stops using it is because it just didn't fit right first time, or they've got the wrong tool for what they actually wanted to do. So we might have sent them something for skipping when actually what they really cared about was playing guitar. And so we normally need to just go back and be like, let's just check what were the aims you wanted to do, and let's reassess. And then we have a conversation with them, and almost always it's like, oh, here was a problem, and oh, we can fix that. And the interesting thing as well is with these, when they're abandoned, they're landfill. Like there's nothing. there's no other person on the planet that will fit this because it's 100% bespoke to Alex's arm. You could probably repurpose, this hook on the end. I think you need to reprogram. I don't really know because there's sensors in here. That's how you open and close it. So I think you need to recalibrate that for the new person. But this part is completely useless because it's 100% bespoke. Whereas with ours, because it's more like clothes, we can just clean it, refurbish it, and give it to someone new. So you can send it back and we can refit this to a new person. So it's completely circular. So, we often have programs where when we make a new design on a new device or upgrade something, people can send back their old limbs, or if they just grow out of them, they can send back their old limbs. We can clean them, refurbish them, spruce them up, and then send them to other places, like other places in the UK, or if we're doing projects overseas, like we do stuff in every continent at this point. We can take it over to Sri Lanka, over to Sierra Leone, and do that, which is quite cool. There's another question. This is great. Just ping them, just anything. I will literally answer anything. I've heard a lot of discussion around your product among prosthetists. Oh, cool. I hope positive. My goodness. And as you said, it's new and different from them compared to the norm. What clinical hurdles have you had to overcome, practically and opinions, experience, preconceptions wise? Am I correct that you're still working on getting it commissioned to the NHS? If so, how can we help make that happen? Please help make that happen. I mean, yes, so hurdles to overcome. Honestly, and not to labor the point, but like the most important hurdle that we found in sort of all of these areas is just, is the user happy? Like, do they genuinely derive value from the thing you've given them? Because when you get that eureka moment where they're like, oh, I can use this to do this, and they really value it, they'll go and talk to their prosthetist or their doctor or other users, and they will convince them. So that's just putting the user at the absolute first has so far not steered us wrong at all. In terms of opinions, experience, preconceptions, I think there's just a massive gap between what like I as someone with two hands would assume someone with outer limb needs, and obviously when you meet clinicians, especially if they're super experienced, they've formed preconceptions about what is useful and what isn't. There's a couple of entrenched ones. Like, honestly, a big one, which is kind of interesting, is this is the trail of logic. So what people will do, say they're funders or they're certain clinicians. I caveat this: most clinicians we meet are amazing. Like, they're like the best people ever. But funders and stuff will say, well, when we provide upper limb prosthetics, most people chuck them away and don't use them. So there's no point funding them. There's no point putting funding into making them better because no one likes using them. There's no point funding them in the first place. And so you get loads of health systems around the world, including to some limited degree the NHS. Like, you get loads of health systems that don't really put focus on upper limb, then rather focus on legs, because it's easier to measure. And so you get this race to the bottom where there's no point putting energy into it because no one likes them, and because no one likes them, there's no point putting energy into them. Whereas, where I would look at it, but when you make them good, then lots of people want them, and suddenly you see that lots of people could benefit from them. So there is reason to now put resources behind them. That's quite a hard one to get over, and I think that's relevant for NHS and commissioning. We just happened to be incorporated. So we incorporated at the start of 2020. So we can talk about lockdown. That was really fun. We were making these from our bedrooms and stuff, but we were incorporated after they closed like the last set of like tenders for NHS supply chain. So we just need to wait for the next tender. So and then hopefully it should be fine, because we're still working with lots of clinicians. But I mean, helping us, honestly, conversation is helping us, like just spread the word and say, hey, have you heard about this? Do you think that's kind of interesting? Because the more there's this groundswell of interest and positive feedback, then I think the people who are making these decisions will look at that and say, well, we can't ignore them. Cool, right, there's loads. This is great. There's loads of questions going in. So how many limbs have you shipped? We shipped more limbs than people we've worked with, if you know what I mean, because some people use loads, they're like super users. We have about 500, 600 families, like users around the world, like in literally every continent at this point, except Antarctica. I always have to say there's none in Antarctica yet. Limbs probably over 1,000. And like I say, we properly kicked that off in 2020. So yeah, it's not bad. For the first year, we were making them literally from our bedrooms while we were locked in place. So that's cool. Right, you alluded at the start to working with users with congenital limb differences as well as surgical amputees. Absolutely, very different, very different types of people. 100%. What do you find to be the difference between the needs of those groups? I should read ahead before I talk tonight. Literature findings indicate many who have limb differences from birth are less likely to use prosthetics, and those groups often challenge the sometimes ableist narrative. Yes, I love this, that they need to be fixed. Are you finding those groups are still interested in your prosthetics? I love that. I'm so happy that you know that. I don't know if you guys are familiar, or if anyone's familiar, or maybe it's a very common thing, the concept of the medical model of disability, and we could talk about whether disability is the right word, but whatever. The medical model of disability and the social model of disability. I didn't know about it. Intuitively, this is how it worked, but I didn't know about it. I came across it recently. Basically, and I'm sorry if people already know about this, but I thought it was fascinating. The medical model of disability is sort of, okay, you are broken in some way. You know, you don't have your arm, which means you are broken. I need to prescribe you things. I need to give you things that will fix you so that you can be a normal person. That's the medical model of disability. Which I guess makes a lot of sense with things like colds and flus and illnesses and just things that you need to just fix. But for limb difference, it doesn't quite work because the other model works a lot better and is more accurate, which is the social model of disability, which is you're a person, you know, you're a fully formed person with hopes and wants and dreams, and you're self-actualized, and you want to do something. And for whatever reason, society around you is not structured in a way that you can do that thing. Like you want to go rock climbing, but there's just no way for you to, there's no accessible rock climbing apparatus or places or staff to help you do that. And I much prefer that way of thinking about it, because if you talk to someone who's lost their arm, you can have this kind of discussion about, what function do you want to get back? Like, I want to be able to feed myself again, or whatever. But if you talk to someone who's been born with a limb difference, they haven't, from their point of view, they haven't lost anything. That's how they've always known things to be. And you talk to these people, and they can do everything. They can do everything we can do. So having a conversation about like you need to be fixed just doesn't compute. It doesn't work. It's not right. Whereas what works much better is taking the attitude of like, what new exciting things can we do together? What stuff would you like to do? Would you like to learn a new hobby? Would you like to learn something? Is there something you've always wanted to do that you haven't done? Oh yeah, actually, I've always wanted to try the drums. I've always wanted to try the drums, but I've never really, because, you know, these guys wouldn't let me or whatever. So it's like, oh cool, let's do that. Let's do something new. And that attitude is just better for everyone. And it sort of permeates these kind of groups that traditionally don't and wouldn't like prosthetics because of the connotations of it. Like I don't really like the word prosthetic because of the connotations of it. So amazing question. There's a massive difference between if you've been born without a limb and if you've lost a limb. Cool. Sorry, next question. This is awesome. I love this. Writing with a rigid pen grip is obviously a different technique. It requires finer motor control of the forearm. Yeah, it's very different. How long does it take users to retrain themselves to write fluently? First thing we ever made was something for Alex to use a pen with. And again, I don't have a picture, so I'm just going to describe to you in incredible detail. But it was basically, to picture this prototype, it was a basketball sleeve, like a fabric basketball sleeve, with bits of plastic that I used the hairdryer to like melt into like a conical shape. And that was stitched on the side. It snapped, so I had to repair it with I used an Allen key and loads of hot glue, and then I hot glued a pen on the end. Alex put his arm through the basketball sleeve, and that's what he was using to write. So it was like this rigid kind of mount. It's the first thing he'd used that he actually liked. He was like, "This is awesome," and put it on. And then the first thing he does is starts doing his signature. And he's like, "Gents, I haven't done this in like 5 years at this point. I've not been able to do my signature." and that was instantly. And so I'm always, I don't have stats. I don't have like, I haven't done a, a controlled study on, how do people go from using finger control to using like shoulder and elbow. But I'm always surprised by the adaptability of the human brain. Like there's so much redundancy in our limbs that most things, if you get the angle right of the actual tool, your other joints can make up and do the same motion that you would have done before. I've yet to see something that hasn't translated. And we're starting to do more with physios to see how that can be used to actually sort of train different muscle groups and do interesting things. So people are adaptable, and that's it. It's just about figuring out how to achieve the task over and above trying to replicate the way they do the task, if you know what I mean. They'd have to do it in the exact same way. How much your prosthetics cost? Oh yeah, we do this all the time. So 25 grand, a few £100 if you were buying it as components. What we tend to do for individuals, is to reduce the cost burden even more, is do it on like a sort of subscription basis, so that you don't have rationing. You can get as much stuff as you want sent to you, and that's sort of like 10, 20, 30 quid a month in the US and the UK. In other parts of the world, it would be a little bit cheaper. The idea is there be no barriers to getting this stuff at all. But we also do contracts with like big NGOs, and then it's even cheaper because they're sort of buying in these big sizes. Like, let's look after 500 people, and then that's cheaper. But yeah, like the price of a phone, like a non-Apple smartphone kind of thing. How does user satisfaction for comfort, cost, functionality, comfort/cost/ functionality with lower limb prosthetics compared to low satisfaction for upper limbs? How do abandonment rates compare? Such a good question. I'll be the first to say I haven't explored legs as much as arms at all, and that might be unusual. I don't know. I mean, lots of people, I get it all the time where people say, sort of like, if we're people who are in the corporate area of prosthetics, they're like, really you should be looking at legs, because legs is like a 20 times larger market for your business. That's a better place to be. It's like, well, yeah, but that's what everyone's done. And what that means is that upper limb devices have not seen anywhere near as much development in total as lower limb, like that, because everyone goes and works on lower limb, which means that upper limb devices and services as well haven't changed. It's really massively underserved. So I like working on arms, but from what I understand about legs, comfort's still a huge thing. It's always going to be a huge thing when you've got rigid sockets or any sort of socket. You're putting all your weight through parts of your body and flesh that aren't designed to have weight put through them in that way. So comfort, but functionality for legs is completely different, because with our legs, and forget this can be wrong, I'm just to make a point, like with our legs, you might do 6 things. You run, you jump, you walk, you climb, you kick things. There's certain, and you can classify them. You can do speed, inclination, like how steep can you walk up, and range of motion and stuff. But hands, oh my God, like you do everything with your hands. There's a million and one things you do with your hands, and that still wouldn't capture everything. So I find functionality is really, and I know Shruti would have thoughts on this as well, but like I find functionality such an interesting topic for arms, because it's so poorly defined in literature. Like we've got these really archaic tests, like how fast can you cut a tomato? Well, yeah. How, like, maybe some people that's their driving passion, to cut tomatoes with their hands, but that's not, not terribly indicative of everyday life. So why is that a functionality measurement for limbs? So I would imagine people who have legs and use them more than people who have arms. I know lots of people who are quadruple amputees, or at least have lost some legs and arms, who they actually do use their legs because they can get around with them. But arms don't bother. I'll use my stumps instead. So from that, my guess would be that arms are abandoned way more than legs. That's a guess. Don't quote me, or do. I was fine. Cool. I was a student at an NHS prosthetic clinic, and I worked with a patient who was on the trial with the ALX. Very cool. I would love to know which clinic. That'd be awesome. One of the patient's main issues was suspending the limb, since there is no hard shell contour to the patient anatomy. It's very true. Like in a prosthetic socket. The other issue was the patient's confidence using the device to hold heavier objects. Yeah, 100%, since the gripper parts of the limb are not as rigid as common prosthetic terminal devices. 100%. So what's interesting is, when we were looking at these, and we're like, well, these are built like brick, houses. These are tough. Like, you could drive over this and you probably need a new car. So if we're going to make things that are soft and flexible, my assumption was that these would always only be used for like lightweight things, riding, eating, moving objects, supporting your other arm, like a slipper compared to a walking boot, was always the assumption. But the amazing thing is, the more people we worked with, the more people use them for stuff that, one, it wasn't designed for, and one that we never thought people would want to try. So like doing heavier stuff, doing like handstands, doing these kind of things. And we sort of realized by them doing that we're like, oh my gosh, this is actually stronger than we think it is. So we're actually in the process now of going through and essentially redesigning all the fixturing and everything to be like, okay, well, now that we know it can do these kind of heavier objects, heavier kind of weight tasks, let's go through and make sure it's actually properly designed to do that. So I would encourage you to get back in touch with, I'm assuming it was Brian that you worked with. I would encourage you to get back in touch with him and ask for our latest stuff, and work with us and let us know which bits we should be focusing on, because you will know, and we will listen and we will do it. Is there a passive wrist rotation, flexion, etc. in your devices? And if so, is this integrated into the devices where relevant? Oh, the socket flexion is coming up more and more as a positive addition from physios, especially for when people are sat at their desk. Interesting. So we have passive wrist rotation. So that's what this is. So it's sort of like friction. We're going to introduce some indexing and locking is the next thing, because again, this wasn't designed to do anything that would need to be locked, but people want to. So that's cool. So there's passive wrist rotation, which is good for eating. So like people will like put the fork in, push it along, and then move it to their mouth, and then push it back, and so that's quite nice. Flexion, I'm assuming, because this is engineer, not anatomically super savvy, but I'm assuming you mean sort of like this, being able to do that. So it's like that, this tool being able to come there and go there and stuff. We have some other tools that mimic this in ways. So this is like one that's on a ball joint. I didn't even explain the tools. You can sort of, lots of stuff is cylindrical, so it's designed to hold cylindrical objects, and we also have like grippers as well. But yeah, this is on a ball joint, so you can move it to the angle that you want and then lock it off. We normally don't recommend this for people who've lost both their hands because it's fiddly. So we're working on something like that. Or we have ones that index in different directions, but it's not necessarily a standard. So it's interesting. If that is becoming more and more important, then that's something we should look at. And also, I don't know how the best way to do it, but I'll share my email. Like, I would love to, like people who are like super interested in this and have good ideas and know more than me. Please email me and let's carry on chatting, because this is awesome. And really helpful for me. Can we see your conical basketball thingy? Okay, I'm going to try and quickly. I'm so bad at multitasking. I'm going to try and find it while also talking. Because I do have a slide deck with some pictures on. Can you look at semi-flexible socket like they use a bit more in the US? I think it's called a 3/4 socket or something. I think I know the one you mean, where bits of it are rigid and bits of it are sort of like, I've never actually held one, but I'm assuming it's like sort of like a silicone-y, rubbery thing of some hardness. Yeah, from what I've heard, those fare better in lots of situations than fully rigid sockets. So I would have thought what we'd be doing would be obvious. Maybe it is to many people, but to show you how this works. So this fabric layer is essentially a cover. So this can velcro off. It's what tightens the limb down. This can be anything. So I also have like an Iron Man one, because if you hadn't guessed, I'm a loser. But so this is what we call the blank. So this is like a semi-flexible sort of structure. You put it into a cylindrical shape and it's tough as anything. But so this is what can sort of like bend and mold and be malleable around someone's limb. And then this closes it off. And especially we spent a lot of time figuring out where on this structure needs to be very flexible, semi-flexible, very rigid. So I think it's the same kind of, or at least a high level, same kind of philosophy. So I think it's a really good idea, personally. But then I would say that. So you just mentioned folks with double limb differences. What, if anything, do you find to be different about the needs, wants of folks with no hands versus folks with one? From what I know, from the people I've met, I can only speak to the people I've met so far. For people with one hand still around, the other arm is very optional whether you have a prosthetic or not, because you can do stuff with this hand. You and I probably, if we both have both our hands, I made an assumption, I'm so sorry. If we both have our hands, we're probably mostly one-handed dominant anyway. Like if you mapped what our hands are doing, this is doing, I'm right-handed, this is doing pretty much everything, and then this is occasionally supporting it. So if you lose the actual hand on this, you kind of use your stump. So a prosthetic, again, is very much an optional thing. So there's no point trying to fix this person because they're fine. It's much more about working with them to make stuff that's interesting and new. For people who've lost both their hands, that's a real hit to independence, especially in those first few days and weeks. Like you've just woken up from surgery. You need to relearn everything with limbs that are really sore. So you can't even like force your way through it. You're kind of left alone. So for those guys, we try and give them really soft devices, because normally you can't wear prosthetics for, at least 6 weeks for everything to heal. But more often than not, it's a few months before you can wear a rigid prosthetic. With ours, you can wear it like 40 minutes after you wake up, which is epic, because then you can have a simple tool. You can text your wife and be like, I'm awake, the morphine's awesome, kind of thing. And it just brings that level of independence back. So I think the main difference I find or hear from people with double limb differences is that prosthetics are more of a necessity than people with single hand limb difference or unilateral limb difference, and that the tasks you do are more what me and you might intuitively think of, like writing, eating, these kind of things. Whereas if someone's got another hand, chances are that's the hand that's doing the writing and the eating. Like you don't need this prosthetic to do it. Why is lower limb such a bigger market? Does it just come from upper limb demands being more complex and hence there being greater development in that area? Or are there more people who need lower limbs? Such an epic question. So yeah, I think it's, as everything's, multifaceted, isn't it? I think, well, one, the numbers are more. There's more people with lower limb injuries than upper limb. Diabetes is a huge one, because I think diabetes the effects of it affect your extremities. And I'm assuming because your legs are further away from your heart than your arms are, they're the first to go. So your legs go from diabetes, and your feet. So there's that. Things like conflict and war, like if you step on a mine, it's probably that part of you that's getting messed up. So I think things like that. And then lots of diseases that are sort of coming and go, like polio affects legs, I guess, more than arms, I'm assuming. So there's multiple factors like that. So I think you've got this natural tendency for there to be more leg amputations, say. I won't speak at all to the congenital limb difference. I don't know the breakdown, but there's generally more leg amputations. And I think that makes companies look at it and say, well, that's the bigger market, that's where we should start. So there's more development, which means there's more visibility. So more people will use legs and they'll talk about legs, which means that other people will look and see, oh, there's stuff to do in legs, and sort of this self-fulfilling thing. That's a good kind of melting pot of getting new ideas. Upper limb is, unfortunately, I think, suffering from the opposite. No one's doing anything in it because it's smaller. and therefore less people do stuff, so less people engage, so it looks smaller than it actually is. So because the thing that isn't mentioned as much is that although there are more lower limb amputations, unfortunately people with lower limb amputations live less long than people with upper limb, because upper limb is normally like trauma, so they're normally quite young, whereas lower limb is sort of like diabetes, which goes a bit older. So even though the lower limb markets maybe, or lower limb amputations are maybe 10, 20 times more common than upper limb, the actual prevalence of people living with the stuff is, I think it's 1 to 2. So I think, a third are upper limb, 2/3 are lower limb. So there should be more in upper limb. There should be more people working on upper limb. Honestly, it's like, come on in, the water's warm. There's loads of stuff to do here. Are there any electronics integrated into your prosthetics? Do you plan on using more electronics in future devices? Yeah, so our very first design, I'm going to try. Oh, how am I going to do this? I'm on one screen. I'm going to try and share my screen to show you this crappy prosthetic. Is that okay? Someone shooty shout if I'm going to break everything, but let me try and share this. Bosh. I don't know if you can see this. I don't know how I can tell if
we can see it.
Hey, so why don't I go to slideshow mode? Bosh. That's prosthetic. This is Alex, guys, absolute legend. He's like my favorite human. He's just so funny. This was us as young dumb students. Now I'm just less young, but about as dumb. And that is the first prototype. And would you like to see Alex's reaction to it? Yeah, he's really happy. He's not. He's like, "Are you joking? This took you 9 months." But this one is the one that he wrote his signature with, and you can see it there in the top right. That's the picture of him writing his signature. And you can see the Allen key as well. So it's like, and this is the one he was like, "This is amazing." And we're like, "I can't believe this combination of stuff you like," but it's because it works, which is just really funny. Sorry, that was a little thing. I see there are more questions. Should I answer? Do you want to? I don't know. I could take these away and answer them in my own time, or I can just race through them now. What do you reckon, Shruti?
I think if everyone is happy to stay, please do. We will not be offended if you leave. This will be recorded, and it's being recorded and will be uploaded. So you will be able to find it online. But I would say the questions that are written, if you can rattle through them, and then we'll wrap up after that.
I'll rattle through them. How can funding for research into the brain? Oh, I didn't even answer. Sorry. So the point of that was saying we did have electronics in the first one. It was a bionic hand. We had muscle sensors here. It's really old EMG, whatever, they weren't old, but like it's old technology. EMG sensors here, open, close, and there were different grips. But we started, instead of asking what was cool for us to make, we were asking people, what do you want us to do? And still to this day, we haven't come across something where someone's asked for something that they want to do that we need to put electronics into it. And so we haven't yet, which has been very useful, because then doing our CE marking is so much easier if you don't have electronics. So that was a godsend. But we will definitely be integrating electronics, because the way we've designed it is to be a platform. So you can clip anything on the end, you can put anything on it. We love working with unis and researchers and other companies that are doing this, and we want to build their stuff in. So we're starting to do that more and more. So yeah, we watch this space. I'm sure we will do in the future. How can funding for research into the brain, prosthetic, motor components be maximized? Can we rely primarily on government funding, or can we maximize on research funded by engineering companies as an investment for future sales and product development? Oh, I won't get too cynical about prosthetic company development. They're probably just more likely to just make more of the same stuff they're already making, because it makes amazing margins and their businesses are very large and there's no need for them to do new stuff. I think unis are an amazing place. Honestly, schools and unis, because actually the technology needed is not complicated. High school students can code this and make a bionic hand if they want to. and play around with different motors and stuff. I do think we should have more innovative motors in terms of actuators. We should have better actuators these days. I can't believe we still use linear actuators and stuff like that. Like, we should be deep into, and we probably are, I'm just ignorant to it, but we should be deep into like electroactive polymers and shape memory alloys, like things you can weave into fabrics. Like, we should be, that's what actuators should be now. They should be these motors that we've had forever. But I think, yes, unis are a great place to do it. We love working with unis. Call us if you want like a corporate or like a company partner. I think that the one thing that the best thing you can do is make prosthetics projects for students, but then just hammer into them. Like, I don't want you making anything that's not 100% driven from a user need. Like, stop making things you think are cool, make things that they ask for. Then I think we'll get some really cool stuff if you put all these bright minds on those kind of things. And you get loads of funding because it would be new. Everything would be like different. If ends are cheap and easy to swap, are the tools, yeah. Having several alternate angle ends might be stronger, easier to use than a single adjustable end. I like where your head's at, Rob. That's exactly where I started. When we were 3D printing them, I was like, I can't be bothered to make a mechanism. Let's just have 3 different angles. And people like that. There was a middle ground to find between having simplicity of design and a person just having like hundreds of different tool ends like scattered around. And so we try and do it so that if it should be easy, it should be super simple for the user to use, but if to get to that point we have to do lots of complicated engineering behind it, we'd rather do that than us do simple engineering to make our lives easier but make it a bit more inconvenient for them. So there's a balance, but you're absolutely right, and that's what we generally tend to do. So that's it. Hot and cold sensor might be a good case for electronics. I also like where your head's at, Rob. I think it would be. Maybe we're doing something with that. I don't know. Who could say? I don't know. But
Okay.
have I missed any? Or is that?
I mean, we have more coming in, which is absolutely great. It's fantastic to have such great engagement from the audience. We may not be able to see you, but I'm loving all the questions.
Yeah,
and I'm going to wrap up because we have just run over. But Nate, your contact details, if anyone has any questions or want to get in contact, are you happy to just put them in the chat? We have also been tweeting this. I did miss a few questions. I'm really sorry. My fingers got tired. But you will be able to find Koalaa on Twitter as well. If you find us, you'll find them. Easy peasy. But yeah, Nate has put his email address on there. So yeah, thank you so much. And Nate, thank you so much for agreeing to do this and chatting. There was you thinking I would have to be making up questions for you. Clearly not. Awesome. So yes, thank you everyone so much. This webinar session would not have been as good and engaging without you. So yeah, thank you so much. That's everything. We'll let you enjoy your evening. For our future events, keep an eye on our Twitter, on the IET website. Everything's on there. But have a great evening. I hope some of you have some evening sunshine. And yeah, I'm gonna wrap up here, and the webinar will be available online for you as well if you do want to rewatch it. Thank you very much, everyone. Have a good evening.
Thank you, guys. Thank you for inviting me as well. That was awesome. That was fun.
Thank you. Bye.